Hey, welcome back. So for this week, we're looking at 3.9. So for the first part of that, we're looking at multiplying. So we're going to take two binomials and multiply them together, as well as a binomial times a trinomial. So for the first one and for a bunch of these, you're going to be using FOIL. So first, outer, inner, last, x times x is x squared, x times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. Combine our like terms, so we have x squared plus 10x plus 25. And there's our answer. Now this is what's called a perfect square trinomial, because both the first number and the last number are perfect squares, and if we multiply them together and multiply by 2, we get the middle number. All right, the next one. So for this, we're going to distribute the x to everything. So we're going to have x to the third plus 3x squared plus 9x. Then we're going to distribute the negative 3 to everything. So we have minus 3x squared minus 9x minus 27. So now we take and combine like terms. So we've got an x squared and an x squared. They cancel each other out because one's positive, one's negative. We have a 9x and a negative 9x. Once again, they cancel each other out. So we're left with just x to the third minus 27. So this is a difference of 2 cubes. So this is a difference of 2 cubes. X to the third is a perfect cube, 27 is a perfect cube, and it's a difference because we have, because we have the subtraction. Okay? So that's what you're looking at in that first section. It's going to be a lot of multiplying either two binomials together or a binomial and a trinomial together. All right, so now we're going to look at the book. So we want to state the y-intercept, the degree, and the end behavior for each of the given polynomials. So if we look at this, our y-intercept, remember, is always going to be the constant. So the y-intercept is 0, 8. The degree is always the largest exponent. So if we look, the largest exponent is 5. So it's a degree of 5. And then for end behavior, what's that asking is as x is approaching negative infinity, so as we're going down, or as we're going to the left, our f of x value, so our y value, is going which direction? So because we're dealing with a degree of 5, it's going to alternate. So odd degrees will always alternate going from negative to positive. So this will be to negative infinity. This will be to positive infinity. Now, this would be flipped if we had a negative on our x to the 5th term, but we don't. So that's why it's from negative infinity to positive infinity. So any of them that are an even degree function or an even function will have different end behaviors. They'll be opposites, whereas if you have an even degree, they will have the same end behavior. So that means in 14, our y-intercept is 0, negative 15. Our degree is 4. The end behavior, well, this is positive, so that means they're both going to positive infinity. So just like that. Alrighty, so evens are going to look like that. Odds are going to look like 13. All right, moving on. So identifying even and odd functions. So identify each function as even, odd, or neither. So if we look, what kind of function is this? It's even. It's a squared. And what kind of function is this? It's odd. It's cubed. So keep that in mind as you're taking and doing these. Look at the exponents to help you. All right, for this next section, The expression a squared plus 2ab plus b squared is called a perfect square trinomial. I can recognize it because the first and last terms will always be perfect squares. The middle term will be 2 times the, remember we just talked about this, first and last terms. There will always be a blank sign before the last term. So in all the ones that we had, it's always plus. So an addition sign, I'm just going to write the plus sign because it's kind of small. And it factors as, so a plus b, a plus b. Or it could have minuses there. That is also possible as well. So it could be a minus b times a minus b, or it could be a plus b times a plus b. Either is possible. All right, you're going to do 21 on your own. 22. Pardon me. The expression a cubed plus b cubed is called the sum of two cubes. I can recognize it because it's a binomial and the first and last terms are cubed. The expression a cubed plus b cubed factors into a binomial and a trinomial. I can remember it as a short, and this is going to be, I'm going to bring it down here, binomial, and a long trinomial. The sign between the terms in the binomial is addition, as the sign in the sign between the terms in the binomial is addition, as the sign in the expression. The first sign in the trinomial is the opposite of the sign in the binomial. That's why all of the middle terms cancel when multiplying. The last sign in the trinomial is always addition, and it factors a plus b times a squared minus ab plus b squared. So this will help you with what you have on the first page with dealing with sum of two cubes, perfect square trinomial, and difference of two squares. Okay, so your keyword for this lesson is factoring. Factoring, because we're dealing a lot with factoring. All right, and this last section, we're going to go back to my whiteboard for. So what we're taking and doing is factoring with what we know. So looking at this, what kind of equation is this? Is it a difference of two squares? Sorry. A sum of two cubes or a perfect square trinomial? Perfect square trinomial, because 25 squared is a perfect square. We get 5x. And 9 is a perfect square. We get 3. If we multiply 5 and 3, we get 15. If we multiply that by 2, we get our 30x. So we put parentheses around it and square it. So what you're doing for that last section is taking and finding that factored form. All right, so like I said, this is your only lesson for this week. Your keyword is factoring. Have a wonderful week and happy mathing.